Hello Geometry, this is lesson 5.1. Our objective is how to use the mid-segments of triangles and how to do coordinate proofs. Alright, so first off, the mid-segment of a triangle is a segment that connects the midpoints of two sides of a triangle. Every triangle has three mid-segments. So here's a picture of one. P is the midpoint of the side BC because this length is the same length as that length, right? Midpoint. It's halfway between. And same thing over here. M is the midpoint of these sides. So this line right here, MP, is what we call a mid-segment. It says the mid-segment of triangle ABC, this one's out here. These mid-segments for our triangle are these, MP, MN, and NP. Now the mid-segment theorem is a pretty powerful theorem. It says two different things. It says the segments connecting the midpoints of two sides of a triangle is parallel to the third side. So this is parallel to this one is parallel to this one is parallel to that one. And then also that it is half the length. So MP is half the length of AC. Which means if we wanted to add some tick marks here, MP is going to be the same thing as AN. And MN is going to be the same thing as BP or PC. And then this one is going to be, NP is going to be the same thing as AM and MB. Alright, the diagram of an A-frame house, DG and DH are mid-segments. Let's go ahead and just maybe highlight those. DG is this line right here. And DH, that's this line right here, are mid-segments of triangle ABF. So let's go ahead and just draw that ABF. That's that triangle. Find DG. So what I'm looking for is the length of DG. So I want to know this length. And BF. How long is this length? Alright. Well, first of all, let's kind of transpose that triangle out here just so I can see a little bit easier. Here's the length that I'm looking for. Here and here. Those are the two lengths I'm looking for. I have these. Now notice here it gives me this 12 feet. It says from right here to right here is 12 feet. So this length is 12 feet. And it tells me that this one right here is 10 feet. So remember, the mid-segment theorem says that this mid-segment is half the length of this one. So if I want to find this length right here, which is DG, is equal to 1/2 of AF. So it's going to be 1/2 of 12, which is equal to 6 feet. Now, I can kind of apply that same rule here. I know DH, that's this one right here, is equal to 1/2 of BF. Problem is now I'm looking for this BF and I have the DG. So I know 10 is equal to 1/2 of BF, which is what I'm looking for. So since BF is being multiplied by 1/2, I'm going to multiply it by 2, which is the reciprocal. So that means BF is going to equal to 2 times 10, which is 20 feet. So it kind of makes sense. This is half the length of that, so that means this must be double the length of that. This is half the length of this, so that means this must be double the length of that. So DG is 6 feet, BF is 20 feet. Alright, the next thing we're looking at is in the diagram, RS is congruent to TS. So let's go and mark that RS is congruent to TS. And RW is the same thing as VW. Show that VT, this line, is parallel to this line. So I would say, go ahead and let's write a little proof for this. RS is congruent to TS, and that RW is congruent to VW. That's given. That means S is a midpoint of RT, and W is a midpoint of RV. That's just the definition of midpoint. That means WS is a midsegment of triangle RVT. That's the definition of midsegment. That means WS, let's go back, let's say that means VT is parallel to WS. And that is the midsegment theorem. Boom. All right, the next thing we're talking about is coordinate proofs. And coordinate proofs involves placing geometric figures into a coordinate plane. And what we do is we represent the side lengths just with letters versus with a particular number, because then we can apply what we've learned to any of those general case shapes. So let's look at this one here, like example 3. It says place a square and a right triangle in the coordinate plane in a way that is convenient for finding side lengths, assign coordinates to each vertex. So we're just going to sketch a graph here. I don't want red. Of a coordinate plane here. This is going to be my x and my y-axis. Now I'm not going to put a scale on this just because make this a little easier. So let's go ahead and place the square. Notice we are doing and, we're doing both, but let's go and start with the square. So I'm going to do the square in blue. So I'm going to come up here and draw my square like this. Okay. Now notice I put one of the points right here at the vertex. That makes it easy whenever I'm trying to calculate like side length or something like that. So here's one corner, 0, 0. And let's call this side length S. So each side is side length of S. So as I come up to this point up here at the top left, my x-coordinate is still 0, but I have moved up the length of S. So my y-coordinate is now S. Likewise, on the bottom right, my x-axis, my y-coordinate is still 0, but now I've moved to the right S in length, because each is the square and each side length is S. Now that kind of helped us get our top right coordinate. Now I've moved to the right S for my X, and I've moved up S for my Y. So that point is SS. Now it also wants a right triangle. And so I'm going to go ahead and put that in here as well. I'll put a point here and a point here. Connect these. So now we're looking at this right triangle right here. So notice that point 0, 0 is still there. Let's call this side length M and this side length N. So this right here, the bottom right, it's going to be M in length and M0, right? Because I've moved to the right M, but I haven't gone up and down any. This one up here, I have not gone left to right any, but I've gone up N. So it is 0, N. So if I were to prove something for this red triangle, it would apply to every right triangle. Because I'm not using the length of like 2 and 3, I'm particularly using the length M and N, so it would apply to any right triangle. Same thing if I applied something for this blue square, I'm proving it for side length S, so this would apply to any square that I wanted. Here, like example 4 says, place a rectangle in a coordinate plane, then find the length of a diagonal and the coordinates of the midpoint M of the diagonal. So let's go ahead and try to put one of these on here. Alright, as you can see, I've drawn the rectangle up there in blue, and diagonal I've drawn there in red. So to find the length of the diagonal, I could have gone the other way from point 0, 0 up to xy. Either way would be the same. So I'm going to use the distance formula here. The square root of x2 minus x1, so it's going to be x minus 0 squared plus y2 minus y1, 0 minus y squared. So it's going to be the square root of x minus 0. It's going to be x, and then I'm squaring that. 0 minus y is going to be negative y squared, which is going to give me y squared. So the length of that diagonal is going to be the square root of x squared plus y squared. And then the midpoint, is just going to be, add the two, so it's going to be 0 plus x over 2, and the point y plus 0 over 2. So the midpoint then is going to be the coordinate x over 2, y over 2. Your homework, if you haven't seen it already, starts on page 300. You're going to do 4 through 30 even. Good luck, guys.